Bismillahirrahmanirrahim. Today we're going to solve further problems which will be helpful in MDCAT especially, and they are valid for other tests as well. We know that the numerical problems in physics becomes easy by practice. So you have to do practice as much as possible. So let's start. Keep one thing in your mind, that you have to be very precise, tricky and to the point in solving such problems. When you solve with tricks, you will get good results. So let's start. This is the first one. A block of mass 20 grams. So this is the first thing given to you. Mass is thrown vertically upward with a speed of 10 meter per second. This is a speed. So this is mass, which is 20 gram. So we'll convert it into kilogram, because we have to solve all such problems in System International, and unit of mass in System International is kilogram. Then come to the speed. It is thrown vertically upward in this direction with a velocity or speed which is Vi. So Vi is 10 meter per second. The work done by the force of gravity during its upward motion is. So now you have to use your trick. What's that trick? The work done by the force of gravity during its upward motion. Motion is upward. The direction of gravitational acceleration is downward. So both are in opposite direction. So your result will come with negative sign. Either this will be the option or this will be the option. When this will reaches to its highest point, its velocity will become 0 because it stops further moving, and then it will go back downward. So Vf will be 0. G is 9.8 meter per second square. Work done will be equals to the change in kinetic energy. Means what? Kinetic energy final minus kinetic energy initial. The formula of kinetic energy is half mv square. So in case of final velocity, mvf square. In case of initial one, half mvi square. So w equals to 1 upon 2 m. Vf is 0. This is half. M is 20 over 1000. This vi is 10. You can notice one thing. Here I have not written the value of m. Why? Because I know that Vf is 0, so there isn't any need to write down the value of m and waste your time, because it will come out as 0. So this is 0, this term is 0, leave this term, only focus with this one. Now look at this, we have leave this because this will become 0, this 0 goes with this 0, this is 10 square. So here we'll have another 10 and remove this square. So 10 with this 10, 0 with this 0 and this 0 with this 0, this is 2 and this is 2. So left with minus 1. The result is minus 1 joule. Again, in another way, this will 0. First one, this is 1 upon 2, this is 20 by 1000 and this is 10 square. So 10 into 10. So multiply the numerator, we'll get what? 2000. In the denominator we have 2000. This is the negative sign, so cancels, and you will get result minus 1 joule. So this is the correct option. Now move to the next one. An 8 kg box. So mass is how much? 8 kg. Slides along a horizontal frictionless floor. Means there is no role of friction at all. At 3 meter per second, velocity is 3 meter per second, and collides with a relatively massless spring. The condition is like this. This is moving in this direction. This is the spring. Spring is nearly massless. When it comes over here, it strikes to it. As a result, this will be compressed. The mass compresses 12 centimeter. This is this displacement 12 centimeter. In the form of meter, this is 12 over 100. Before the box comes to rest, the box will come to rest. Calculate the retarding force of the spring. We have to find out the retarding force F. Initially the box was in motion, so it has kinetic energy, which was given as k is equals to half mv square. M is 8, v is 3 whole square, so k is 36. As the box was moving, when it comes to rest, whole kinetic energy of the box will be transformed into the potential energy of the spring. Potential energy of the spring is given by half kx square. This kinetic energy of the spring is completely converted into the potential energy of the spring. So potential energy is now become 36 joules. Now substitute in this equation, we'll get what? 36 equals to half k, and x is 12 over 100 whole square. Now this will come over this side. 36 to the 72 k, and this is 144 over 1 with 4 zeros. It was having 2 zeros, with the square it becomes 4 zeros. When this will come to the other side, we will have 72 into 1 with 4 zeros divided by 144 equals to k. This is 1, this is 2 times, 2 ones are 2, and this will 2 5s are 10 and 3 0. K is equals to 5000 Newton per meter. F is equals to kx. So F is equals to k is 5000 and x is 12 over 100. So force is 600 Newton. So your correct option will be second one. Come to the next one. Two bodies with kinetic energies in the ratio 4:1. So the kinetic energy of the first body is Ke1, second body has Ke2, ratio is 4:1, are moving with equal linear momentum. Their linear momentums are equal. The ratio of their masses is, kinetic energy is related to the momentum with the formula Ke equals to P square over 2m, P square over 2m1 divided by P square over 2m2, and this is 4:1. Why I didn't write P1, P2? Because their linear momentums are same. When you move further, you will convert divide into multiply and you will get this result. This will remain same, this side will be inverted, and you will get 4 over 1 over here. So P square cancels with P square, 2 cancels with 2. We will left with m2 over m1 equals to 4:1, or when you invert it, so the required ratio is 1:4, this one. Now move to the next one. Again interesting one. I have taken interesting and difficult problems for you, not every problem. A man holding 10 Newton weight in his hand, say this is a man and this is his hand, this is 10 Newton weight, moves 5 meter horizontally. He moves 5 meters horizontally and 10 meter vertically, then he moves 10 meter vertically. Find the work done by the man. You can see that in the first case, the force of the person is moving in this direction. He has lifted this, so force is moving upward. So the angle between force and displacement in first case, this one, here to here, is 90 degree. Means what? We know that the work done will be 0 when the theta is 90 degree. The angle between the force and displacement is 90 degree, result will be 0. So in the first case, we won't get any work done. In the second case, we can see that the direction of force is this one, as over here, and the direction of displacement also in the same direction. Okay, the work done, which is equals to F dot D, we can write FD cos theta. F is 10, this is also 10 displacement, and cos is 0 degree. Cos 0 degree is equals to 1. So W is equals to 100 joules. This is the correct option. Move to the next one. Which one of the following is the angular velocity? Angular velocity. We have to find out angular velocity of an electrical motor if it is revolving at 400 revolution per minute. So when you look at the revolution per minute, you can find that it is also indicating the angular velocity. Then what we have to do is, when you look at the options, you will find that the options are given in radian per second. So we have to convert revolution per minute into radian per second. So what's the conversion? 1 revolution equals to 2 pi radian, complete cycle. 1 minute equals to 60 seconds. We have to convert what? 400 rpm, so we'll multiply it with 2 pi divided by 60. Make it easy by converting pi into 3.14 into 100 by moving this. So 1 time, 4 time, 4 ones are 4, and this is 15. So this will be 628 divided by 15. So we'll get result 41 point something. So this is the correct option, 41.9. So that's the result. You can see this calculation.